Welcome to our very special event with Walker Farrell from Make Noise as our guest. First, a few sentences and stories from Walker, and thank you for coming here, and please welcome Walker Farrell. And
Thank you very much, Tomas, and thanks to Schneiders for hosting me here. I've worked for Make Noise I've worked full-time there for just over 4 years, had my fourth full-time anniversary the other day. Originally, I started as an intern in early 2013, and did that for about 6 months, and then was brought on full-time pretty quickly, and so I've kind of lived and breathed Make Noise for several years now. I was a user of modular synthesizers for several years before I started with Make Noise, and so to be able to be in and with modular synthesizers all the time, every week, has been fantastic for me for the last few years. A brief background of Make Noise for anyone who's not already familiar. It was started in 2008. Tony Rolando is the founder of the company and remains the head engineer, does all the circuit design and panel design for all the analog modules that we make. Sometime in the first couple of years, even started adding digital firmware to some of the modules as well, so we do a hybrid system that's both analog and digital. So in 2008, Eurorack had been around for a while already with Doepfer, but it was really just beginning to go beyond Doepfer and a few other manufacturers. So at the time, you were likely to have a Doepfer system that might have a couple modules by somebody like Livewire or Plan B, or the Harvest Man was one that was just beginning, and those makers were all very influential to Tony, not only in the circuits that they were creating, but the fact that they were starting to do things that were going beyond what modular synthesis had been to that point, and the fact that you could mix and match your system around the sort of concepts and theories that you wanted to do. So his first module that he created is called the Mod, and it was basically a passive ring modulator with an unusual circuit configuration that gave it a strange sonic signature. And he made, I think, about 20 of those on the first production run, and was surprised to find that it sold out immediately and was reordered by what was his only dealer at the time, Analog Haven. And so from there, he began to start to go a little farther, and even I think at that early stage, look at the long game of creating a full instrument out of individual modules. So some of the early modules that Tony first started with are very much influenced by people like Don Buchla and Serge, West Coast synthesis. And however, even from the beginning, he was always funneling in many different influences. He's very influenced by Dada art, which is something that you can see on the panels. And there's also a strong connection to electronic music, the composers of electronic music from early and mid and late 20th century, as well as just the instrument makers too. And Tony worked for the Moog company for a little while before he started with Make Noise, and he's always said that he's very influenced by Moog as well. It was not necessarily until somewhat later that the explicit influence was put into his instruments, but even from the DPO, he was insistent on putting a hard sync circuit into the left oscillator, for example, which is something that is normally associated with the East Coast and is prevalent on like the Mini Moog Voyager, which he had worked on at Moog. And even though the DPO has a layout and structure that's in some ways reminiscent of the Buchla 259, it's also influenced by the Mini Moog as well. So he was kind of aiming for that mashup right from the beginning. Let's see. So for me, the first module that I got from Make Noise was maths, and I think that's probably true for a lot of people. And maths is something that kind of ties a lot of concepts from synthesis, and especially West Coast, so to speak, synthesis into one object or module. So we've got one in this system here, and I'm going to go ahead and patch some sound from the DPO here. That's pretty loud.
It's the only module we really force people into by saying that math really is a module that teaches you modular synthesis, because it entails all the techniques that make modular synthesis so very interesting. Every system needs a math.
Not only one.
Well, I tend to agree. So the thing is that maths, I think that one reason that people love maths so much is it takes some simple concepts and combines them together to make something that's more than the sum of the parts in a lot of ways. And just to give a real quick overview of it, its basic idea is that of a slope generator or slew limiter, something that causes voltage to go up and down at various rates, whether it's slowing something down that's moving or generating its own. For example, the up and down motion of this function, we have a rise time that we set for how long it takes to get to the top. And then we also have a fall time that we set for how long it takes to go back to the bottom. And when it's self-cycling like this, you have an LFO, which you can also make go quite a bit faster so that you get the audio rate kind of modulations that clearly would not be possible by hand. And then we also could just use gates or triggers to cause it to go through a single time and just be an envelope or function. So where maths, of course, gets more complicated and interesting can be in using the sum output to combine multiples of these at once. So we have two channels that are both doing the same thing at different rates here. And when we combine them together, we get something that's more complicated. The other thing that I think is kind of important to the design philosophy of Make Noise is that we tend to make things that are modeless is a word that gets brought up some during design, which we have in the case of the maths, there's a lot of ways to patch it so that you could do these 35 or 50 or 100 different things with it. But these things are all they're built up from building blocks rather than having a list of modes that you're picking which one you want to do. Instead, you're taking the different functions that are already there and combining them in and creating whatever behavior it is by patching it specifically. So you're kind of directly connected to the concept of whatever it is that you're doing. And you and the circuit are working together to create these things rather than kind of going from a list that's provided by a designer. So, and I think that's something that you'll find is the case in a lot of the Make Noise modules. Let's see here. So I also talked about the DPO a little bit. We have two oscillators on the DPO which are independent in their own frequencies from each other, and they each have several waveform outputs with different wave shapes. This too is typically seen as a West Coast type of module, which is has a strong connection to the Buchla 259 dual oscillator from the 60s and 70s. And one thing that's really powerful about the DPO is the fact that the two oscillators are connected together just already within the circuit, and they're made to interact with each other in a number of ways before you begin patching it. For example, we have frequency modulation that happens when we turn up the FM bus. In this case, we have the left side being an LFO, and we can control its frequency, and its sine wave is automatically bused to the frequency modulation inputs of the other. And if we put it into audio rate, then it becomes a timbral modulation instead of pitch modulation. And then we have these timbral controls on the final output here, and they can also be controlled by that left oscillator. And we can do pitch and timbre at once if we want. Now, of course, you have actual CV inputs for all of these functions as well that you can just patch something else into if you would prefer. So I'd say that in a lot of ways, the maths and the DPO form the core of the Make Noise system, but we, even early on, Tony was thinking about trying to build it up into a full instrument, which could be something that was a known factor that he grew to learn from sitting with it for a long period of time. And the end goal there was eventually achieved in the shared system. I have a black and gold shared system here. It's got a couple extra modules that have been added to it, but this is essentially when you're looking at a shared system, you're always going to be looking at this same collection of modules. And so it's something that we have grown to know very well since we always take it to every event like this and trade show, and I've shown many people how to use synthesizers by teaching them this system, and it's become something where the layout of this system is as much natural to my own hands as something like a guitar or a trumpet would be, because you know where each thing is and each control, and they're all made to flow together in a particular way. So we previously had some sound coming out of this. So by the time the shared system was kind of released as an instrument, Tony had added several other modules. We've got the sequencer Renee, which is a nonlinear sequencer that's controlled by touch plates. And then we also have digital effects built into the system as well, so you can hear the sound of just this, the analog side of this. I'm sorry, I have a bad connection on one side here. And then we have digital delay with the echophone and digital reverb with the verb. And for these modules, we have worked with Tom Erb from SoundHack to create digital algorithms that are specifically made to be highly modulatable in the system that is a modular synthesizer. So for example, we could take the verb has very wide-ranging size control. And we can modulate that if we want to. something like the size of a room changing rhythmically is not something you find typically in nature. So that was part of the idea behind the reverb, is to kind of remove some of the connections between different elements of what reverb would be. You have room size, you have pre-delay, which is going to tell you how long it takes for those echoes to come in. So that if you use longer pre-delays, you could actually be using it almost as if it's just an actual echo, like a delay unit. And we can tempo sync that as well. And we can even turn the reverb reverse here. So in addition to being a reverb that is going to sound nice to put sound through and add space, we also have the ability to kind of morph the elements of the sound that you normally wouldn't really have that kind of direct control over. And that's something that Tom Erb of SoundHack is particularly good at. Let's see if we've got time here. So let's see. Does anybody have any questions about any of those so far? I know we've only kind of scratched the surface. So the other thing about the shared system is that it was specifically made to be used by a set of musicians for a record series. And so the shared system record series started to come out in 2012 and 2013, actually just before the shared system was released as an instrument that you could buy. And the original shared system was unique. It was the only one that there was, and it was sent one after the other to several artists: Richard Devine, Robert Aki Abrilo, Keith Fullerton Whitman, Surichai, and Alessandro Cortini. They each recorded a two-sided single, 7-inch single, with using only the shared system as their only instrument for the records. And part of the reason for that series there was to highlight the versatility of sound that could come out of this one instrument. So different artists with different kind of perspectives and styles were going to make pretty wildly different types of music out of it. And if anybody has any of those records, then you know there is quite a bit of diversity there in sound. So let's see. And then in the last couple of years, we've started adding going kind of in some ways more back to basics, and then in some ways into some newer territory where we've never been before. And the first would be more back to basics would be the Zero Coast, which is a standalone synthesizer that is patchable like modular, but is also easily controlled using a MIDI keyboard or your digital audio workstation, what have you. And it is it's been a big hit for us. I think it's introducing a lot of people to these type of concepts in a lot of ways. And we've also recently released a couple of modules that are coming directly out of the Zero Coast. We've got the Dynamix and the Contour, which are here in this bottom case here. And these generally are modules, the first modules we've made that really in some ways come from the lineage of the East Coast synthesizer that tends to be controlled by a keyboard. So the Dynamix is a VCA, which, let's make sure we've got some sound. So this is a VCA, but it's also kind of a low-pass gate because it has some filtering involved in its the way that the sound is modulated. So when we turn up the amplitude, we're going to hear a brightness being added to it as well, hearing more of the upper frequencies as we turn up the amplitude. And then when it goes lower in amplitude, it's not only going to get softer but also more dull in sound. And that element of it does come from the low-pass gate as created by Don Buchla, which we make some low-pass gates with the Optimix and LXD. But unlike those, the Dynamix has an immediate response to control voltage. So when you send it an envelope, turn this back up, it's going to follow the contour of that envelope immediately and exactly, so that even when you go pretty fast, you're getting exactly what you tell it to, instead of having a little bit of a tail that's added to the sound as would be with the classic low-pass gate. So, and this is particularly well suited to being controlled by a manual gate with an ADSR envelope, which is exactly what the contour is. So these two circuits pulled from the O-Coast are kind of expanding the types of control that the Make Noise system is made to respond to. And then, like the Optimix and some other modules we have, the Dynamix is also a mixer. So it's two channels of that fast low-pass gate action, and then we can add, we can chain another item to it with the aux input, and we have some control over dynamics as well, kind of like a crude compressor or limiter, things like that. Expansion, side chaining, stuff like that can be done with the dynamic inputs. And we might go into that in more detail later if people have questions about that. And then the other one that we've really been focusing on this past year is the Morphagene, which is music concrete, tape music, and micro sound module. So that itself is kind of two directions at once. We've got the lineage of tape music from the 50s and 60s, music concrete, things where we're taking sounds that are not necessarily having an originally musical origin and starting to manipulate them for musical purposes. The sounds here are actually sounds that were recorded at Make Noise headquarters when people on the production line were building the single row skiff that we sell. So this is the sound of the sliding nuts that you use to screw the modules in are being slid down the rail and installed in the skiff. Sounds like some cardboard or maybe bubble wrap, something like that being ripped. That's tape for sure. So our idea here is you can take really any type of sound, whether it's considered to be originally musical or not, and be modulating it the same way you do with synthesizer modules. So we have the speed of playback, which is based on a vari-speed control on early tape machines. And then it can also do reverse and direction. Pick a different one. So that was that sound of the sliding nuts falling in and ringing out. You can hear it has quite a different kind of shape to the sound when it's played backwards, actually. And then we also, in addition to speed and direction, we have the ability to zoom in on smaller and smaller pieces of the sound and move through them. And then we also have a control called Morph, which will allow us to set how many of these little pieces we're going to be hearing at once. We can go all the way from there being a little bit of a gap between one piece and the next to it being seamlessly looping, and then we can start to add additional copies as well, so that it sounds more dense. And when we really crank that up, it'll start to begin to randomize some elements of individual pieces as well, so that we get different pitches, different places in the stereo field. Now we're having sounds that don't really sound like they came from metal on metal, but they almost sound more like radio transmissions or something. And then depending on what sound we're using, we get very different results. And of course, this is all modulatable as well. Why is the company called Make Noise? This might be an example, I guess.
You did already.
And we can also we can mix in the sound of what's coming in from outside. The idea that it can be, that was a quick and dirty version, but you can integrate it into the rest of what you're doing in the synthesizer as well, record things from the synthesizer into it and manipulate them in the same way, process it with the digital effects, what have you. So so that's kind of what we've been working on the last couple of years, specifically Morphagene and the O-Coast were our big releases for the last couple of years. We're always working on new stuff as well, but the Contour and the Dynamics are our latest releases for this year. I see a question there.
How can you get new sounds into it?
There are a couple ways. You have what I was using right here to monitor the this synth sound here is in fact an input. You have stereo I/O here, and you can record sound into it just by using button combinations, and then in that case we can move to a recording that I just made of that. Just even things like adding additional layers of morph to it can almost be like delays and things right there, and then you of course have another thing you can do is do overdubbing, where we just would record it over itself over and over again. Now it's just going through that same time period that it's already been in and just repeating whatever modulations I give to it with each time it moves through again. And then it also has a micro SD card reader built into it. So anything that you record in with an SD card in will be saved, so you can bring it back again later. And it's also possible to create the reels that it uses by using a computer. So it's pretty flexible how you bring sound into it.
Could you elaborate a little on what makes this combination and layout of modules have that flow that you mentioned?
Oh yeah, absolutely. One thing that is very kind of focused on when it comes to the design of these modules is definitely ergonomics and how they're going to fit together in a bigger configuration. An example is the CV bus, which is made to create a patch situation in which you don't have to use very many long cables. And in this case, I've got a patch here with like maybe 15 or 20 cables in it, and the only long cable I was using was to connect to the other case. So what this does is it takes signals and distributes them through the middle of the system, and then it makes copies of them. It's a multiple that are color-coded. So for example, I patched a clock in here into the orange channel, and then it comes out all these other channels and allows me to access it at various different places in the system. And then there's a tendency, especially more recently since the designs have been integrated into the system, for things like audio and CV outputs to often be at the top of modules, especially modules that are made to go in the bottom row and be controller modules. Things like the Tempi, pressure points, Rene, things that we're going to touch a lot. They have easy access to these touch plates or buttons here, and then their outputs are all right there next to where the CV bus is, so that they're just ready to be bussed around the rest of the system right there. I think that part of what Tony has always designed any given module with an idea of where it would be in a case. And for a perfect example would be these modules, especially because they're designed to be accessed without your fingers running into a bunch of cables and things like that. And then there are other elements like the sizes of the different knobs. Bigger knobs are typically more important and dramatic parameters. So something you're going to reach for, and your hand is going to find that and have wide range of motion with an easy to grab there. That was a terrible sentence, but I think you know what I meant. And let's see, there was something else I was going to say as well. One thing that I think actually separates Make Noise from a lot of modules is the fact that the signal flow tends to be depicted in the layout of the module. So, for example, on the Echophone, for example, we have an input at the upper left. Okay, let's not listen to that. We have an input at the upper left, and there is, I guess you can all see this on the screen here. There's a line that goes from the input into the input attenuator, which is going to set the level of what's coming into it. And then we could see it going through the mix control and coming out the output. Similarly, for the CV parameters, we have a pitch control here that's controlled by a pitch 1 and pitch 2. They have lines that go up to the attenuverter that sets how much and what direction of modulation it's going to be. I should make this an example you can hear. So let's change that sequence up. So for example, I go into pitch here, and I'll go in with something that turns it up and down. Oops. So when I turn this farther up, the depth of that modulation is going to increase. As I turn it down, it's less modulation. And then as I turn it the opposite way, it's actually going to make it go down instead of up. Whoop. Nah, I had a feeling that was going to happen. But anyway, the fact that the input is then pointing through the attenuator and then to the panel control is something that you don't find on all synthesizers. In many cases, you have an input with a label somewhere, and then somewhere else a panel control with the same label. You're going to go, okay, I want to do pitch, and then find the pitch control over here. Part of an idea behind the design of a Make Noise product is once you've used it some, you're not going to be reading anymore. Instead, you're just going to be grabbing those controls because you're learning where those signals are going. Does that answer the question?
That's great.
Awesome. Now I'm wet, so. Good question, by the way. Yeah. Any other questions right now? Thanks, Tomas.
Yeah, can you talk a bit more about the nonlinear sequencing with the Rene?
Yes, definitely.
Topic, yeah.
Yeah, so I'm barely demonstrating it here with this patch. I mean, it's doing a nonlinear sequence insofar as it's not going through these locations in a straight line, but it's also doing the same sequence every time. You can see it going in that zigzag pattern, and it's going through the same set of notes every single time. So, and I've set that up because that way I could demonstrate it really easily as part of the overall system, but I'm going to switch a different mode here. The real concept behind the Rene is that the locations of the sequence are not organized in a line the way they often are in step sequencers. Instead, they're organized in an X and Y grid, Rene being named after Rene Descartes, who came up with the idea of the Cartesian grid with X and Y coordinates to tell you where you are. So in this case, instead of having 16 notes in a line, there's 16 notes in a grid. Okay, so I'm clocking the X clock right now, which is causing it to move along the X axis. If I move over to the Y clock, well, for one thing that does is turn off all my gates, but it moves on the Y axis, in other words, vertically, right? So when it starts to come alive is if I clock both at once. Now I have an X clock happening for every fourth Y clock based on the relations I've set up on the tempi here. But let's change it so the Y clock only goes 3 times per X clock. Now in this case, like if you do the math, it's not gonna repeat until whatever the lowest common denominator is of 3 and 4, I guess. 3 and it's going through at and changing every third step, so we have a different pattern through. If I so here it is repeating, but it's more than 16 steps before it repeats because it's going well, actually I guess it's going exactly. Slow down the X clock enough, I'm going much more vertical than I am horizontal. So the other thing is that you can do things like turn individual places off, so it won't go to these places that I've turned off on the access page. Slow this down. And then we also have some controls over where it kind of starts from. You have these CV controls that let you move them around, and you can use that to kind of create motion on the axis that's not tied to a clock. For example, I can use this math cycle here to move it on the Y axis. And right now that's not related to the X clock at all, but I could make it so that it is if I instead of trigger that. And then I could like maybe randomize what's actually happening here so that it's a different speed each time. So that's one example of a pattern that's not really linear. It's not 16 notes over and over again. Instead, it's like clocking through the locations differently. And then you also have you can change what notes are being played, of course, at any given. Let's get that out of here. And then you've got your control by your fingers as well. So anytime you touch the touch plates, the Renee will only go to the places where your fingers are allowing it to touch.
So you're setting the pitches by turning the knobs?
Yeah, so each knob is a location that's associated with. It can be a pitch or it's just a voltage, but they are specially made to control pitch. So I've taken the quantized CV out and patched it to the volt per octave input. It also has control over which notes are actually activated. So, for example, if I turn off all but one, I just get it's going through octaves, and then if I turn on like a fifth. So you have a number of like custom scale and location configurations that you can also save and recall as well.
Could a step be a pause or a rest?
Yeah, well it'll go whenever it gets a clock, so that can take as long as it takes for the next clock to come. You can also, if you're talking about a rest wherein it goes to the step but it doesn't play a note, then you would use gate programming for that. So a good example for that would be to, there's more than one way to do this, but the simple way that I'm going to describe it here is to put it back in the snake mode, which I had before, which is going to do... I'm going to go back to a pretty simple sequence here. Let's speed this up. Okay, so in this case, I've got several gates that I'm putting out from the X gate output, and this is I've actually been using it to open the low pass gate here, so the sound's only coming through when the gate comes through here. On the X gate page, I can turn individual gates on and off. So if you were to patch like this, then that's the simple way to do rests. Another thing you can do is turn off stages on access and set it to a sleep mode where it won't go to stages that it's not. It'll wait until it finds a stage that it's allowed to go to. So it's kind of like there's several different approaches to that kind of thing. I also like to do things like take the Y output and use it for something different from what the X output is doing. Like, I mean, what we're hearing here is just using the X output to create notes, but if we were also to use the Y output to then when it moves up, we get this other embellishment that's added to it. And depending on where the motions are happening, depending on which pattern it's going through, you will get different rhythmic patterns here. Other questions?
One question, I would start collecting questions, exactly.
Since you can make a digital copy of everything that you have on top analog, is there a noticeable difference between the digital sound put through the machine again than what you have originally?
Do you mean like if I were to record this sound into the Morphagene and play it back?
As we were doing with the module, do you see a noticeable difference in the sound now that it's digital sort of?
I do not, because the Morphagene records and plays back at 48 kilohertz and 32-bit audio. So, in fact, before the Morphagene, we had a module called Phonogene, which would do a similar thing at much, much lower sample and bit rate. And it really imposed a certain quality on the sound. And when you changed its speed, it was changing the sample rate. It added a lot of aliasing and digital artifacts, which was part of its charm in a lot of ways. But when I started using the Morphagene during development and recording sound into it, I had to get used to the fact that when I switch over to what I've recorded, I would think I was listening to the synth because it sounded exactly the same. And I could just record a little bit in here. Personally, I really enjoy doing something new each time because even though I already know things pretty well, I'm finding new perspectives each time. So I have to say I don't think that's really something that modular is very strong at is exact repeatability. Your best bet is to use something that's like a computer program or something that's made for it, in my opinion.
Well, the old analog memory.
There is the analog memory, that's true.
That was a funny thing,
That's an expander module for the pressure points that it basically is just sending, it's storing a bunch of positions of knobs. They're not stored they're only stored for as long as you leave it in the same place though. But it could be used to shift between a whole bunch of different configurations of parameters that you leave patched and then switch between. I know that a guy who used to play a Buchla 200E with the Haken Continuum, I want to say Richard Lanehart maybe, what used to do, he basically had a single patch that he used for the last like 8 or 10 years of his life. And based on changing presets on the preset manager of the Buchla, he was able to get a vast amount of variety out of that.
There's another.
Yes, sir.
The Morphogene and the Phonogene, are there big difference other than the sampling time?
There are some pretty big differences. The Morphagene is stereo I/O, that's one. The sampling time and quality. The controls work somewhat differently on the Morphagene. Mostly, the biggest difference in the way that it feels to use is that the gene size and slide controls are completely continuous. So instead of progressively chopping it into smaller pieces, it's like a window that's moving, that's changing size and location very smoothly. And then it adds the morph control, clock time stretching, CV out envelope follower, the ability to record additional material onto the end in a new splice for iterative music, and then storage and recall with the SD card. There's more, I think, but it's got quite a bit of new bells and whistles.
The Phonogene is extremely sexy.
The Phonogene, I have to say that I can't get the Morphagene to sound like the Phonogene.
No, exactly.
So I'm still using both of them myself.
There are almost two different modules.
They really are,
With the
yeah.
Phonogene, you tend to play with the specific artifacts.
The Morphagene was not made as a... I mean, it was definitely inspired by the Phonogene, but it was built from the ground up. The Phonogene wasn't coded by Tom, so it's not a sound hack module. The Morphagene was built from the ground up for this hardware platform.
What is
Hey.
the format of the audio?
On the Morphagene, it's in wave format. Yep.
Yeah.
Yes.
Going back to the no cost. Okay, I don't know if this question will be funny, but what would be the next module you will get in addition to no cost in order to unlock the creativity? Because I have it and I have the Ecophone and I don't know what to get next.
So I get that question a lot. I get that question a lot. I have a lot of people come in and say I have a no coast and I'm ready to get some modules
Analog
too.
filter, I guess.
Uh,
Analog filter.
I don't know. I don't use those, but
Really?
maybe every once in a while. Well, that's true though. The no coast does not have a regular analog filter on it, so if that's something that you are interested in, then that's one. But usually I ask people, are they looking to expand and process the sound, or are they looking to expand and get more in depth with the control? And eventually you probably want to do both, but it's a matter of what your priority is. So often I recommend an Ecophone, so it sounds like you're ahead of the curve on that one. The other ones that I think are really always useful for it are basically the same modules that I'd say are the core of a modular system. You might want a second VCO to mix with the balance and thicken up the voice, or do multi-voice sequencing. You might want some complex voltage generation like maths or like the Woggle bug, depending on whether you're looking for something that's more repeatable like maths, or something that's really just going to add a lot of motion that's not as loopy, repetitious. And so usually I typically either say another VCO or a maths or Woggle bug for control, or else some effects, just depending on where you want to go next.
And that's a question posed quite often or frequently popping up in the store here. And please come by during our opening times and we can work something out. As the Zero Coast is a complete voice and limited and limitless at the same time, usually the thing you miss the most when working with it is the right thing to buy next. And quite often it's a second VCO filter. Where's Toby? Something like that. Hey. Walk.
Yeah,
Yeah.
I want to.
Ladies first.
Yeah, because I thought maybe you can tell us a bit about the CV bus you have there in the shared system.
And why we
because I
can't
think it's
buy
a
it.
really clever thing, and people maybe.
I'll tell you a little bit about the history of it to begin with. It was made because Alessandro Cortini was touring with his system with 9 Inch Nails and was finding that he was always trying to come up with more and better strategies for reducing the amount of patch cable clutter he had in his system when he's on a stage with lights and everything, and it could get confusing. And Tony's idea around that was to make it, not only so you're not using as many longer cables, but also so that if you're multing signals, normally if you don't have a CV bus, you'd normally be using a mult, which would just be a module somewhere that has a bunch of jacks on it that you plug one into and then copies come out elsewhere. What happens there is you get these clusters of cables that are then kind of coming out radially to everywhere else. So with a CV bus is just distributing them evenly across the system. And then you've got the color coding of each channel. So any signal that I patch in here, I'm going to get it on a different channel. So I've got the green channel, the orange channel, the yellow channel, and the red. And so that gives you a shorthand to which channel you're using, but also the LEDs are gonna show you what the signal is. So, for example, if I'm taking the this maths here and just slowing that down, we can see that we have essentially clocks on the orange and red channels here. They're just flashing, turning on and off, whereas the yellow channel is something that's continuous. It's changing slowly. As I change the frequency of this maths cycle, we'll get something that follows what it looks like. And then finally we have, they're showing not only the strength but also the polarity of the signal, because if I make it negative voltage, then it comes out on the bottom of that ring there. So it's kind of a number of little concepts built into one to not only cut down on patch clutter, but also give you a really immediate visual shorthand for what type of signal you're about to be patching into. And I find I use it for clocks more than anything else. It works for audio as well.
But it's only available in the Make Noise systems, is it?
It is. It's part of the system, and we also sell it as part of this case without the other modules in it. Otherwise, you need a custom case that's made with a 1U row to put that in there. I think that they only sell it like that when we've already shipped all the systems that we have orders for. So it is a rare beast, I guess. But it's a concept that I had never thought of, and I don't think anybody had really thought of before Tony invented it. But I feel like it's kind of one of those Edison light bulb type things where as soon as I saw that it existed, I couldn't believe nobody had thought of it before. It seemed like really obvious and like necessary in retrospect.
Same as with the Rene, where this X and Y question is X and Y thing is so simple that you're like, oh God, why didn't I?
Absolutely. Those are like the best kind of ideas where it's a simple idea that somehow nobody thought of before. Did that give you enough info, Jesse? Thanks.
No,
I was going to ask about the Woggle bug. So maybe you could talk about Tony's approach to randomness.
Sure. The Woggle bug also has a foot in history of synthesis. It was originally a module for the wired synthesizer designed by Grant Richter. And he was the person who coined, as far as I know, the term East and West Coast. He was building a synthesizer that encompassed both of those approaches. So he was doing low-pass gates, complex waveforms, but also resonant filters and the ability for keyboard control and stuff. But the Woggle bug is definitely a West Coast concept. It's coming out of one half of one of the Buchla source of uncertainty modules. So it's basically just several types of voltage, random voltage that are all related, but they're not the same. And he did some things that Buchla had not ever done. I have one up there now. Let me just take a second to repatch here. With the Woggle bug, you've got several flavors. So the stepped random voltage is it's just random voltage. Each clock gives you a new step, and you can change how fast it is. Actually, I'm going to attenuate that some so you can hear it better. As you turn that up. Now, this random voltage is actually driven by a sample and hold, so which is to say that if you put something into the external input, you can make it follow it. So I'm putting this math cycle here into it. As it goes up, the output goes up, and as it goes down, the output goes down. and it samples based on the clock rate. But then I've got the ego and id control here, and as I turn that up, it's going to start to add randomness to that. So what we have is really a controllable random. You still have, this shape is still going up and down, but you don't know exactly where it's going to land around that shape at any given time. And the farther you turn this up, the less it's going to sound like the original. Turn it all the way up and you're back to just totally random again.
Could you say that it goes from randomly created and repeating to randomly created and never repeating, and you can browse all the shades in between?
Sure, if you're using a repeating voltage into it, it's because what's happening at the left side of this control, it's entirely based on what's coming in. So this is a repeating voltage, just going up and down. If I change the shape, I get it. But if I were to use a voltage that's not repeating, well, now it's not repeating, but it's still following what's happening
The
at its
more you
input.
turn up the ego knob, the more variation you introduce.
Yeah, and at the maximum, it's just nothing but it's ignoring the external entirely. So that's the stepped output, and the external input affects all the outputs, but so it affects the step, the smooth, and the woggle. The smooth output is one that's going to follow the stepped output more slowly. So it's like the stepped output, but with some slew added to it. So you have smooth motion from one step to the next. And just similarly as with the stepped, if you use something repeating in it, then it's still following it, but not quite matching it. And then finally we have the woggle output, and this is something that follows the smooth output. And this was really Grant Richter's big innovation, was to make this woggle output, which is something that you can control how good it is at following the smooth output. So as you turn it up farther, it gets sloppier and sloppier.
Is it the same circuits which used in the DPO?
No, it's not. The woggle, the follow in the DPO is different. So the woggle is actually based on an audio output that's built into it, which is this. And it has two audio outputs. So what happens inside the circuit is the smooth random drives this VCO, which as you can hear is going all over the place because it's random. And then the woggle VCO is a phase lock loop. And I don't know if that means anything to anybody, but it's another oscillator that attempts to match the pitch of the smooth one, and it does kind of a bad job. The worse you turn down the woggle control, the more it's gonna like have little variations built in when it's reaching there. You get those little what they call woggles. And then from that woggle output, he's generating a voltage that's called the woggle CV, which is now driving my DPO. So if I were to take the woggle VCO and mix it with the sound of the DPO, then you could hear what they sound like together. I need to get some of these other cables out so you can see, but so basically one of those is the actual woggle bug making the audio, and the other one is the woggle bug using that audio to tell the DPO what to do.
Yeah, got
And then you can also still mix in the voltage that it's following here.
Make noise.
Again.
And then it also has the random gate outputs, which are based on the relation of all these different outputs to each other.
You can also imagine it as a system within your system that's dedicated to creating random events gradually between random and full-on chaos random.
Yeah, the
Maybe
key
something
is
like that.
definitely that you have control over how random it is. But so it's not, even though it can be just totally insane, the idea everywhere in the system is, depending on how you patch it, where you patch it to, how you attenuate and shape that voltage, you can use it to just kind of subtly modify stuff or to just make it totally chaotic and everywhere in between.
And also to make it audible, you were using it on a VCO, but of course you can also use it on a decay of an envelope, on the
Oh, yeah.
Y and X parameters of the René to subtly introduce some changes.
Yeah, absolutely. In fact, I almost always use pitch to demonstrate the shape of voltages because the ear can catch onto it really easily. But it's you get, the more you remember to use every type of voltage to modulate other things too, the more you remember that every single element can be patched to every single one, the more things are going to come together and have this way of a bunch of different elements that are all tied together and related, and they get that organic quality to them.
Another question. If you were to use Morphagene via Ableton, how would you communicate?
Use it with Ableton?
Yeah.
Well, you'd have a couple options. I mean, it would mostly be communicating using the audio inputs rather than CV, because Ableton's not going to generate CV unless you're using something that's made to do that, like Expert Sleeper's software or something like that. But you could record. You could use the Morphagene as a processor for audio that's coming out of Ableton. Or you could, if you could be using it to generate material that you sample into Ableton and map onto a drum pads or something like that. In fact, another reason that I'm in Berlin right now is for the Loop Festival this weekend, and I will be there with a push and Ableton, using it specifically with the O-Coast, but I'm going to have Morphagene on hand too.
So well, with the audio processing, it's very clear actually. But when it comes to controlling it, then would you say then we would need a René?
Okay.
If you want to use it as a sampler, not just for random purpose, but like to have a planned composition.
I mean, it is definitely made to be controlled by control voltage. I would say that if you had a modular system that's just a Morphagene, you're missing out because it's not made to be a whole instrument. There you have other possibilities. I mean, you can run Expert Sleeper's software and send voltages from Ableton that way if you have the hardware for it. It's kind of complicated to set up maybe, but can definitely be done. Or as far as like gates and things, you can actually send audio pulses out of your interface and use that to clock things. You could use that to clock the play or record inputs on the Morphagene, or the clock input, which does some time stretching stuff. So if you were to send a sequence of pulses in whatever rhythmic formation you want, it would be controlling it. If you have a no-coast, it has also the MIDI outputs here. You could send MIDI from Ableton, and then you'd get a channel of CV and a channel of gate that you can send into the Morphagene or any module to control it there too. So there are a bunch of options. They're just not quite as robust as having a full modular.
Not yet. Yeah.
Not yet. Yes.
Aside from the lateral stuff to generate the CV, And as long as you've got a DC coupled outlet or expert seeders, you can.
Yeah, that's true. You can use with DC coupled outputs. If you can use max or yeah.
Really fun ones I found with the Morphagene was clocking on the cord, but also the splice. So you can run in instantly, slice up a breakbeat or something. Classic stuff.
Very nice.
One question, talking about sequencing again. I've seen pressure points used as a touch controller, but I'd heard there's an add-on module that made it sequence as well, and then I was wondering how you find maybe using that combines with the Rene, because I imagined you could almost trigger arpeggios or something by triggering the Rene.
Yes, definitely. They're I think they work together really well. I'm sorry, I interrupted you.
No, yeah, I was just wondering how they interact or what some certain ideas just might be.
I'm guessing that it's like impossible to see what's happening
Oh,
here,
yeah.
so I'm gonna go ahead and pull all these cables out.
That's classic modular technique.
This is my favorite patch right here.
Yeah, and whenever you do that, you can be sure that something new and exciting will happen when you start anew. And in a nutshell, what Walker will be doing is sequencing a sequencer with a sequencer that can be controlled by the first sequencer maybe, and so on.
That was good. Well, the first I'll show, since I haven't talked about the pressure points yet, I'll just show like how it works briefly. We can take the pressure points it's connected to the brains module, which is the one you'd mentioned. This is what makes it into a sequencer. But essentially, it's going to generate gates when you touch the touch plate. So you touch a touch plate, and you can see the gates being generated on the green channel here of the CV bus. And then each row of knobs here has a set of values that you set. Just like a sequencer, just like on Rene, basically. So by setting 4 different levels there, I basically have a little keyboard. Now, if instead I use the clock input on the brains, then what I'm getting is it's going through and it's sequencing just 1, 2, 3, 4. Unlike Rene, this is a linear sequencer. They always go in a row, but you can jump wherever you want using the touch plates. And then it also has these pressure outputs, which you can use to generate a voltage based on how much of your fingers touching the plate. So if you want to use, this is a very simple sequence what I have here, but we could also use it in conjunction with Rene. For example, if I'm clocking this and clocking Rene at the same time, I could use pressure points to sequence timbre while I sequence pitch with Rene. That's a simple way because you could kind of do this with just one sequencer since they have multiple channel outputs. But another thing you could do is, say we're sequencing with Rene. Now, what we could do is use pressure points to kind of transpose. I've patched one of its rows to the other Expo FM input on the VCO. So if I were to clock this on at a different rate, like a slower rate, let's make this more dramatic. now we have something that's repeating in a different sort of way. Let's see. And if you start to do them in a way that's not synced, then you get something that's much less obvious, but it's kind of, I don't know, most obvious if you are doing both at once. Let's see. Now we've got, each note has 4 different timbres before it moves on to the next one. So this is something I definitely could not do with just one of them. I needed both to do it. The Brains also has things that tell it when to run and stop, for example. Every other note and stop on the next note. We could use other channels of it to set other things like the speed of the echo.
And you were saying something in conjunction with the math, that was the word modeless, and I think that also applies to this combination, that for every musical idea you can conceive there is a way to do that modular, and then there are the ideas that you can only come up with these modules that are suddenly showing you new inspiration and new territories, where you're suddenly in a dialogue with the system. And
definitely. And I think that's why something like using a Brains and pressure points along with a René, in some ways, I think that's more powerful than using one sequencer that has 8 outputs and different channels that you can program. Using these things together, you have a more like from the ground up kind of organic connection that's happening between them that you're using to create the structure that you're using for the music here. So there's plenty of a million ways to use these together, though. So did that answer your question? Awesome.
Closing words. I'm trying that, but not really closing remarks, but just entering the next stage, so to say. As you said, a million ways with modular synthesizers, and of course also the showroom can be used to try everything out and to find new approaches and to get to know modules. But thank you, Walker, for these deep impressions.
Thank you for having me.